back with Mrs. Ma Abdurrahman, science teacher. Let's continue together the properties of elements in modern periodic table. The third property is metallic and non-metallic property. Elements in periodic table are classified into four main kinds: metals, non-metals, metalloids, and noble gases. Metals are elements have less than 4 electrons in outermost energy level, whereas non-metals have more than 4 electrons in outermost energy levels. During chemical reaction, the atom of metallic elements tend to lose their outermost electrons and change into positive ions and gain positive charge equal to the number of lost electrons. But non-metals gain electrons and change into negative ions and gain negative charge equal to the number of accepted electrons. Let's take an example: sodium and chlorine. Sodium is a metal, loses one electron to another non-metal, which is chlorine, which has ability to accept this electron and form ionic compound, sodium chloride. And both of these atoms reach to the structure of nearest inert gas. So we can say positive ion is an atom of a metallic element which lost one electron or more during the chemical reaction, but negative ion is an atom of non-metallic element which gained an electron or more during the chemical reaction. Now we talk about metalloids. They are elements which have the properties of both metals and non-metals. Give reason. It is difficult to know the metalloids from their outermost electrons due to the difference in number of the electrons in their valence shells, as we see. We are going to know the graduation of metallic and non-metallic property in modern periodic table. In periods, each period starts with strong metal in group 1A, and metallic property decreases till we reach metalloids. Then the non-metallic property appears and increases till we reach the strongest non-metal in group 7A and ends in inert gas. All these happen because atomic size decreases. But in groups, as we go from top to bottom in group 1A, the metallic property increases as atomic size increases. So cesium is the most metallic element in group 1A, but lithium is the least one. But the non-metallic property decreases gradually in group 7A due to the decrease in electronegativity. So fluorine is the strongest non-metal and iodine is the least one. Look at the following diagram, which shows that by increasing atomic number in periods, we find that electronegativity and non-metallic property increase, but atomic size and metallic property decrease. We find the opposite in groups. By increasing atomic number, the atomic size and the metallic property increase, but electronegativity and non-metallic property decrease. Now we will talk about the chemical properties of metals. First of all, when we talk about reaction of metals with dilute, acids, or water, we must study the chemical activity series, because this reaction depends on the position of metal in the chemical activity series. So, the chemical activity series is a series in which metals are arranged in a descending order according to their chemical activity. We must know that the position of hydrogen in chemical activity series acts as a reference, as all metals lie before hydrogen can replace hydrogen ions in its solution and called active metals. But the metals follow hydrogen can't replace hydrogen ions and called inactive metals. Let's see together the reaction of metals with water. you can see potassium and sodium react instantly with water and hydrogen gas evolves, which burns with a pop sound. But calcium and magnesium react very slowly with cold water. Zinc and iron react with hot water vapor, steam, at high temperature only. But copper and silver don't react with water, as they lie down of hydrogen in chemical activity series. Now the reaction of metals with dilute acids. Active metals react with dilute acids, giving salt of acid, and hydrogen gas is evolved, such as magnesium and zinc. But inactive metals don't react with dilute acids, such as copper. Also, we find that nonmetals don't react with dilute acids, such as carbon and sulfur. No reaction happens. Now we will talk about the reaction of metals and nonmetals with oxygen. To know the reaction of metals with oxygen, let's study this activity. Ignite one end of a magnesium strip until it burns. Then put it inside a jar filled with oxygen. It will burn with a bright light, and the magnesium oxide is formed as a white substance. Add some water to this substance, then insert litmus paper in this solution, which turns litmus paper into blue. Repeat the previous steps by using iron. We find that iron oxide doesn't dissolve in water. From all the previous, we find that metals react with oxygen, giving metal oxides, which are called basic oxides. Some of them dissolve in water, forming alkaline solution, which turns litmus paper into blue, and other basic oxides like iron oxide don't dissolve in water. The reaction of nonmetals with oxygen, such as carbon, react with oxygen, giving nonmetal oxides, such as carbon dioxide, which are called acidic oxides that dissolve in water, forming acidic solution, like carbonic acid, which turns litmus paper into red. Goodbye and wait for me for the next video, inshallah.